Hi guys, how are you? In this video we are gonna continue with how to design our pneumatic system. For the topic of today is our dryer selection. So as you remember, we have a dew point of 6 degrees. So that's the reason why we know that we should select a refrigerated compressor dryer. Another thing that we should remember is our flow, compressor flow. That was because in the first video we select a Schuler 45 class that have 7.5 cubic meter per minute, so in liter per second it's 125. And you can also find this data in the data sheet. Another thing that we know is the maximum room temperature. That was our first condition that we set. Something a little bit more. When you are designing or doing a dimension of for your dryer, in the case of pneumatic system, you should know for your inlet dryer temperature should be more 10 degrees more than your maximum room temperature. So what does it mean? That I'm just you have 30 plus 10 degrees, so that's 40. Oh well, okay. 4 degrees for your inlet dryer temperature. Could be more, yes. If you have a more data, you could put more. But for this case, you should just consider 10 because you are designing, you are dimensioning a correct sizing. Our dew point that was 6 degrees. Our working pressure, in this case in bar, 8.33. So maybe you are asking, so why you put 8.33? So if you remember in the first video, I explained your pressure drop. In this case, you have a total drop, your total pressure drop for 2.33. What does it mean? So this should be your range of pressure drop, because your working pressure is 6 bar. So I'm just 6 plus 2.33 because this is my range. So I need 6 plus something more. That more is my drops. So this is my working pressure total that I need. The difference in this case is the 0.5. In this case is also in bar. This is something that is data that is recommended for, in this case, Atlas Copco. So I'm just 8.33 difference with 0.5. In the case you have 7.83. Remember, this is just 6 your working pressure plus your all your drop total, pressure drop total. So now with this data, you would need this table. This also is a table of your Atlas Copco. So I'm not inventing anything, I'm just telling you how to use it. So the first correction factor that we need is in this case, the water or room temperature. You should, with your maximum room temperature, in this case is for us is 30, so we have in this case a 92 percentage. So for our inlet dryer temperature, we are using this case the second lines. So you know that we have 40 degrees. If you remember the inlet dryer temperature, we need the correction factor for that temperature. So for 40 degrees is 0.82. So in this case 82 percentage. And finally for our working pressure, that it sits, we are not consider all that working pressure. We need the working pressure, the pressure that we need in your pneumatic tool. So this is the data that you should select. In this case is 0.96 or 96%. The next step that you should do is just multiply all the data. What you are gonna multiply is all the correction factor with your compressor flow. So that result is the dryer total flow. Uh, your total flow that for your dryer. Now, in liter per second, in the case is 91 if you are more exactly, or for cubic feet meter, in this case is almost 200. So with this data, you are gonna go for your data sheet of all the type of dryer that you have, and you should select one. Well, in this case, I have a data sheet of a refrigerant dryer. This is the for injector run. As you can see, this for where I find this in Kaji. You remember I show you how to search this information for Kaji. For compressors, it's the same for dryer. It's the same. We are gonna do an example in just a minute. So if you can see, in this case, this is the refrigerant type. Well, R4004, and here the test flow is 200, and we have a 198, so it's almost 200. So it's is the immediately net superior, immediately superior. I don't know if it is immediately superior. It's correct. It's okay to say it in that way, but you should go to the net size. So and should be in the market. So in the market, there are 200. So that's the reason why I selected. Then also you should check. Then in this case the dew point, and for in this case we have 40.5 Fahrenheit. That is almost 5 degrees. And remember that we should have 6 degrees. So it's okay. It's totally okay. Our pressure drop. So with these two data that we have, that is the flow and in this case the temperature dew point, for us is okay. Something that I put here checking values, because we have in this case here say 2.7 for pressure drop, in this case psi, in bar 0.19. This is the data that I find for Atlas Copco also. The pressure drop with new oil filters, and for this case pressure drop in this is for dust filters, is 0.08 bar new filters. But because you should know that if you are dimension or designing this your pneumatic system, every part should be new. Also that we have a total pressure drop for in this case of 0.35. I'm just plus this 3 day. Okay, as you can see 0.18 plus, okay, we have this, and we are assuming 0.68. Where I find this, remember that was data for dryer and filter. We said that we are assuming 0.68, but with this refrigerant, with this dryer in the data sheet, we have less, so we are okay. We are in the range, so it's okay. So what does it mean? That this type of dryer, it's okay for our pneumatic system. Now, before I forget it, let's show you how to find in Kaji. In this case, you should go with the performance. Kaji. You should go. Okay. In the performance part, you should, here you have data sheet, and then you go, you just load, and there's dryer, and you start searching every brand as you want. In this case I put this, and then I start just try to find one. Oh, it's slowed. Loading. Okay, sorry. But here you just put it and you can find it. That's how I find this. So okay guys, that's just so simple how to select your dryer. As you can see, it's not difficult. You just should know how to use and how to understand your the correct topics of this. So I'm just on this. So for the next video we are gonna continue with compressed air pipe size calculation, and I repeat calculation. So we are not gonna use a graphic, so we are calculate. So that's for the next week. So guys, I hope this video was okay for you. If you have any question, do not hesitate to do it. Thanks a lot and have a nice day.